Okay, you are welcome back to Introduces Mathematics. Today I'm here to continue my last session in statistics. This is our second session, right? Okay, there was a practical session also. If you are interested with the statistics with R programming, please just go there and check, right? Okay, today my main focus is I'm gonna talk about uh, PMF with PDFs. Right, okay, let's have a glance on this. Last week I have explained that PMF is based on probability mass functions are based on discrete random variables. These are based on discrete random variables. So what about these? These are found with continuous random variables. So I have explained everything with some nice examples. Right, go there. Right, okay. By the way, I'm gonna explain it. I wanna make your brilliant knowledge with this mathematically. Right, okay. Let's do it. This is quite different with our previous derivations. Right. I'm gonna show you what about PMF? What about probability mass function? Right, okay. These are discrete random variables. Let me think these are discrete random variables, right? These are boundaries such as the gap may be delta x upon 2. So what about this a low boundary of this class? This may x1 minus delta x upon 2. Such as this can be written as x1 plus delta x upon 2, right? Such as we have the capability of continuing all these things, right? Okay, I'm going to carry out all these things forward. Let me adjust these here, white balance, sorry, uh, switch it into dark mode, right? Okay, that's better, right? Okay, somehow uh, I'm gonna show you everything with some zoomed in figures because I need to explain these things with a transparency knowledge. Right, right, okay. This is the nearest class, which is the closer one, neighbor classes, right? These are right, okay. Somehow there are some classes with the same intervals, let's speak like that, right? Okay, there are some classes before them. I have figured out only few, right? So here, these are what? These are probability mass. Let me explain you what does it mean by probability mass, right? Each of these bars will denote, the area of these bars will denote the probability of each of these scenarios, right? Okay, so let me explain you. If this is the probability of this discrete scenario, how we can write it. All these counts are all these frequencies. Some of these frequencies are here denoted with upper n. So the corresponding one, which is related to x1, is denoted with little n1. So that can be written as n1 upon upper n. There is no any argument, right? Okay. So the area of this bar can be written as a little n upon upper n, right? So let me show you what's the height of this bar. So with your simple knowledge of mathematics, geometry, you can use it here. Apply. Just simply we can say, what about this height? What about this height? What about this particular corresponding height, which stands for this particular bar? Here. Okay. Little n1 upon upper n upon delta x, isn't it? Yeah, okay. This is called what? Probability mass, not the probability of frequency. Most of the students I have seen that they are really misunderstood of these things, right? Okay, so how you could have any idea, not any idea, you should have a brilliant idea about all these things, otherwise we're not able to carry out all these things into probability density functions. Because in my next part I hope to explain all these things about probability density functions that can be formed with only using this probability mass function. How we can apply limits, right? Limits, let me give you some clues, right? Limits once this class width becomes, we need to let class width go to 0. Then we can make this a pretty much small slide, very small slide. Then it will be look like really I'm really difficult to interpret all these things here. So instead of these polygons, you can see only very smooth curvature, right? So hence we can form these corresponding probability density functions, right? Okay, hope you could have an idea. So I hope to meet you with my third session, probability density functions. Thank you. I am Sakumar saying Sasanka Sagara.